started on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to take a look at some new operators in Python, as well as explore Boolean logic. If you recall, in a previous video, we took a look at a number of operators in Python, such as the arithmetic operators. However, there are many more types of operators available to us, such as the comparison operators. Comparison operators compare two values and return a Boolean value. You may remember the Boolean values are always true or false. Let's take a look. The first operator is equals. This compares two values and returns true only if they are considered to be equal. It's important here not to confuse this with the assignment operator that's represented by a single equal sign. The equals operator, on the other hand, is two equal signs and is for comparison, and it doesn't assign a value. Next, the not equals operator is similar, but provides the opposite function. It checks if two values are not equal and returns true if they're not. For example, 2.5 is not equal to 7.5, so it returns true in this case. The greater than operator returns true if the value on the left is greater than the value on the right. But one important thing to note about this operator is that values that are equal, that have the same value, are not considered to be greater than themselves. So in this case, 5 greater than 5 would be false because the number 5 isn't greater than the number of 5. The less than operator works in the same way, but it checks if the value on the left is less than the value on the right. Again, we have to note that if the values are equal, it's not considered to be less than, and this would return false. So in this case, we see here of 2017 less than 2017 would return false. So to include values as being equal as well as less than, or equal as well as greater than, we need to use the less than and equals to operator or the greater than and equals to operator. These work the same as greater than and less than, but they also include values that are equal as a true result. So what we can see on the screen right now, we have 7 greater than equal to 7, and that's returning true because we included the equals. And we also have 3 less than equal to 3, which is true because we included that equal sign. So keep in mind if you want to be inclusive or exclusive. For inclusive, we want the greater than or equals to or less than or equals to. And if we're exclusive, meaning it doesn't include the same value, then we want greater than or less than. We'll see some examples of that. Let's now try experimenting a bit with these operators in the Python console. Okay, we have the Python console open. Let's try a few different commands. So first, let's do something simple like 1 is greater than 2. You can see that's false. 1 is actually less than 2. So we get a false result. Remember, since we're using the console here, we get the result right away without having to print it. If this is an actual program, you would have to print out that result using something like the print function. So now let's try 2 greater than equal to 2. We also get false here because, as you recall, greater than doesn't count values that are equal. So we could try 3 greater than 2. And we can see we finally get a true result. 3 is greater than 2. Now, another thing we can note is that this also works fine on floating point values. So if we had 1.45 is greater than 1.34, or 24 rather, we also get true here, and we can see the opposite. We could do something like 0.001 is greater than 0.002, and you can see we get false because 0.001 is less than 0.002. Of course, this works with the other operators as well. For example, 5 less than 1,000 is going to be true. And we can also try out the equals. So 5 equals 5. That's true. They're the same value. 4 equals 5 is going to be false because they're different values. And we also have not equals. So if instead we did 4 not equals 5, then we are going to get true because they aren't equal. One thing I'll note here is to be careful of spaces, because if we were trying to do 4 not equals and then we did a space 5, we're going to get an error because we need no space between them. And that goes for greater than equals, less than equals, not equals, equals, all of those have to have no space between those operators, or we'll get an invalid syntax error. We can also try less than equals. So we can say 6 less than equals 6. So I add some extra spaces. And that's true. Remember, when we add in that equals, make it less than or equals, then we get a true if they're the same value. So far, this is probably pretty straightforward for you. But one thing I should point out is we can save the results of these logical expressions into a variable. For example, we could say x equals 4 greater than 5. And you can see on the side here that we have a new variable that's been assigned, and it's been bound to the value false. So we can save the results of these Boolean expressions into Boolean variables. Remember, Boolean variables can either store a true or a false. So if we just put x, we could see it's equal to false. And we can also do something like y equals 7 equals 7. So in a statement like this, it's important to keep in mind which one is assignment and which one is comparison. Remember, 1 equals is for assignment. That means whatever's on the right, we're going to evaluate and store on the left. And 2 equals is for comparison. It's asking a question. Are these equal? So you can see what happened here is we have a new variable 7. It's of type Boolean, and it has the value of true because 7 does equal 7. We could try printing that out as well. Okay, let's continue on with the slides. Okay, as we just saw, we can store the result of comparisons in variables. And we can also do things with the result of those comparisons, such as pass them to another function, like the print function. And when print gets a Boolean value, it'll actually print out the word true or false, just sort of like it does with an integer printing out a number. So the Python program we're currently looking at now inputs 2 values from the user, and then prints the result of a number of comparison operators out for us, sort of like what we just did in the console, but as a program. There's a few new things here that we should mention. First off, I don't think we've covered this in a video yet, but it probably has come up in your textbook, is the input function can be given no prompt. That means we're not giving any string to the input function. When you give no string to the input function, it simply reads in a value without outputting anything to the console. The other thing here is you might recall this from a previous video, but /t is an escape sequence. It represents the tab space character. In this case, it's going to add a little bit of space to our output before the result. So let's switch over to PyCharm and try out this program for a few inputs and see how it works. Okay, we are in PyCharm. Let's give this program a run. So we're going to input 2 numbers. The first one's going to be a 10, and the next one's going to be a 15. So first of all, we should talk about a little bit what's going on here. So this input 2 numbers isn't coming from the input lines, it's coming from this print line here. And then underneath that, we have 2 inputs, num1 and num2. It's because there was no string here, it didn't actually output anything. So this 10 was input into num1 that is, and this 15, as soon as I hit enter, is going to be put into num2. And then we're going to run these little operations on it, and then print out the result. Okay, scroll up a bit. So we have a few things here. We have number 1 is bigger than number 2. So is 10 bigger than 15? That's false. That's what we expect. And this is coming from this operation right here. So this is evaluating that statement. It's returning a Boolean value, true or false, and that's being sent to print. So print first prints out this text. These little /t's are turned into tabs. These are right here. You can see them. Well, you can't really see them. They're invisible, but we're highlighting them. And then it puts a space and then the value here. So when print, however many values you give it, by default, it puts a space between each one and prints it out on the same line. So the next line, number 1 is smaller than number 2. Let's actually fix that. So number 1 is smaller than number 2, num1 less than num2, and we get a true here because 10 is less than 15. The next line, number 1 is equal to number 2. Right here, we have equality. And obviously 10 isn't equal to 15, so we get a false. The next line where it's doing a not equals, we are getting a true because 10 is not equal to 15. And here we have num1 greater than equal to num2, and that is going to be false because 10 isn't greater than 15. And the next one is true because 10 is less than 15. So we might get a little bit more interesting result if we put two equals numbers together. What's a good number? Let's go with 7. Okay, this time we did it with 2 7s. So interestingly here, for greater than and less than, like I stressed before, these are both false because they don't include values that are equal. So 7 isn't greater than 7, and 7 isn't less than 7. But it is equal to 7. So for this line here, 7 equals 7 is true, so we get a true. But 7 not equals to 7 would be false, so we get a false. Now these two are equal. This is the greater than equal and less than equal because they include equality. So if they're equal, they also get true. Okay, let's head back to the slides. And let's move on now to logical operators. So what are logical operators? Well, logical operators allow us to combine the results of multiple conditions that result in a Boolean value, true or false. Logical operators combine the results and then produce a new Boolean value, again, either true or false. So let's take a look at a few. So the first one we have listed here is the AND operator. The AND operator returns true if both Boolean operands are true. By operand, I mean the value on either side, the two values that the operation is considering. In any other case, it's going to return false. The next operator is the OR operator, and this returns true if either operand is true. Otherwise, it returns false. And lastly, the NOT operator. And the NOT operator only deals with a single operand and simply switches its value. If that value was true, it would become false. If it was false, it would become true. So a good way to understand these operations is with a truth table. A truth table shows all the possible combinations of inputs and gives the output in each possible case. Here we have the truth table for the AND operation. The first column shows the values of the first operand, labeled X. The second column, the values for the second operand, labeled Y. And the last column shows the results of performing the operation, in this case AND, on the two values. The rows of the truth table show each possible combination of the Boolean values for X and Y. One row for each combination. For the AND operator, we can see that the only case where the result is true is when both X and Y are true. If either or both are false, the result is false. Here's the truth table for the OR operation. In many ways, this is the opposite of the AND operator. OR returns true in all cases except for when both X and Y are false. If either or both are true, the result is true. Lastly, we have the truth table for the NOT operator. This operator is only performed on a single operand, X in this case, and it simply returns the negation of the value, meaning that the true becomes false and the false becomes true. This might all sound a bit complicated at first, so let's try out some commands in the Python console and get an idea of how this all works. Okay, here we are in the Python console. And we'll start off with something very basic. True and true. And the result is true. The AND operation is going to return true if both sides are true. One important thing to point out here is the capitalization for true and false. That first letter has to be capitalized. Won't work if it's lowercase. Remember, Python is case sensitive. Let's try another example. True and false. And we get false, as we'd expect, and false and false. So pretty much working as we expected, but we can do some more interesting things with this. We can start adding in those other operators we saw and combining them with the logical operators. So combine comparison and logical operators together. So we could say something like 5 is greater than 10, or, so 5 greater than 10 is going to be false, or we could say 6 is less than 100, which is true. So it's first going to evaluate the comparison operator. So we're going to get a false on the left-hand side because 5 is not greater than 10. And on the right-hand side, we're going to get 6 is less than 100, which is true. So it'll be equal to false or true, which should be a true statement because the OR operator is going to give us true if either side is true. And we do get a true result here. We can even test that out, break it down a little bit more, and we could save it into some variables. So let's say 5 for x equals 5 greater than 10. And we could say y equals 6 less than 100. So now we have the results of both of those stored in x and y, and then we can use those too in a comparison like this. So this is effectively the same as what we just saw, except now we're storing those values in variables, and we get true. So we can use these on variables as well as literals. And we can also store the results of these operations. For example, we could say, let's say z equals x or y. And when we print out z, we can see that it is true, just because that was the operation before. And now we can try using the not operator on this. So if we said not z, we would get false, because it flips it around. And if we wanted to do something that we actually make that change to z, because z right now is still true, we could say like z equals not z. And now what this did is it flipped z, so it flipped it from true to false, and then stored it back in z. So when we output it, we can see it's now false. So it's important to keep in mind that these true-false values can also be stored in variables and combined in different ways. We can also use variables in these expressions that store numbers. So for example, let's say a equals 10, b equals 100, and c equals 50. So we could say a is greater than b, or let's do it the other way, make it true. B is greater than A, and B is greater than C. So what this is going to do is it's going to look up the value of B, it's going to look up the value of A, and then it's going to compare, is B greater than A? In that case, it should give true. And then on the other side, it's going to do that comparison first. So it's going to look up the value of B, which is 100. It's going to look up the value of C. It's going to do that comparison. 100 is greater than 50. It's going to return true. And then the result will be true and true. And we do get true in this case. If we changed it around, like for example, maybe we do A is greater than B and A is greater than C. Now we get false because obviously A isn't greater than 100 and it's not greater than C, which is currently equal to 50. We could try another version where we do AC is greater than A, which should be true. 50 is greater than 10. And then we do C is greater than B. Now this one should be false. So a true and a false value should give us false. And we can see that it is. So this can be quite powerful, and we're going to go on and take a look at a few more examples. So let's explore a more interesting problem. How can we use logical operators to check if a number is in a given range inclusively? By inclusively, I mean it includes the ends of those ranges. For example, let's say we have a number line like this, and we want to check if the value is between the two other values, x and y, or is equal to those values, because this is inclusive. How can we do that? For example, let's say that we want to check if this n value is between x and y. So n is currently equal to 4, x is equal to 2, and y is equal to 7. This would result in true, as n is in the range of the values between x and y inclusively. On the other side, if n was equal to 9, we would want to produce a false value because it's outside of the range, as we would if n was less than x. We'd also want a false in this case. If it were equal to x or equal to y, we'd want a true value. So to figure out how to write this Boolean expression, we first need to realize that there's actually two conditions we need to check. The first is that n is greater than or equal to x. If n is ever less than x, we know it's not in the range. The other condition is that n is less than or equal to y. If n is greater than y, we know that it's outside the range. So we use greater than and less than equals in these conditions because we said the range is inclusive, meaning that if n equals x or y, it should count as being in the range. So at this point, we know both of these conditions need to be true for n to be in the range. Either condition on its own isn't enough to check if n is in the range. But how do we combine them? Well, in this case, we want both conditions to be true, so the logical operator we should use is AND. If both n is greater than or equal to x, and n is less than or equal to y are true, we know that n is in the range, and this statement will return true. Otherwise, it's going to return false. So we have an implementation of this in Python with some extra code to ask the user for the number. Let's switch over to PyCharm again and take a look. Okay, we're in PyCharm and we have our program. And there is something a little special here. We've already covered what this does, but let's review. So first we are saying title equals check if a number is in a range. So this is creating a string and it's binding the variable title to it. Now the next line is where things get interesting. We're saying dash, a single dash character, multiplied by the length of title. So however many characters there are in this title, we're going to be multiplying the dash character by that. And then finally, we're adding a line break. So what does it mean when we multiply a string by an integer value, like the number of characters in a string? It means repetition. So this means that line is going to be equal to however many dash characters are equal to the number of characters in the title. So it's going to make a new string called lines that's going to have one dash for each character, because it's going to repeat dash for however many characters there are in here. This is just a fun little way to put a little line under our title, just to sort of like look like it's underlined in the console. If we give it a quick run, we can see what that looks like. So you can see it made a dash for every character in that string by using repetition. So if we tried to change this, like maybe we set it to 3, and we reran our code, we could see we only get 3 dashes. Also, if we want to see exactly what this does, we could try storing that in a value. Let's say x equals this, and we'll change this to x. And now we're going to run in debug mode and add a breakpoint right here. So you can see it stopped right on our breakpoint. And in this case, we have x, and we can see the value of x in our debug interface is equal to 31. So there was 31 characters in this string, and now it's multiplying the dash by 31 to make a new string that has 31 dashes and a line break. Okay, let's get out of debug mode, and let's undo those changes. So this repetition operator on strings can be quite useful for actually like drawing nice windows, little boxes and stuff in the console. The other thing we see here are print title and print lines. This is how these variables are actually getting output. Remember, they don't output by themselves when they're in a Python program like this. Instead, they have to be printed out. So these print out those lines. Let's get that smaller. Let's look at the rest of the code. This is more relevant to what we're talking about. So this is just user input. We're asking the user for some values. We're converting them to integer values. And then we are doing some logical operations down here. Let's add a new breakpoint down here. Let's right there. And let's give it a run in debug mode. Okay, so now it's run this. We've got their title. We've got our nice dashes. So it's asking input low end of the range. So we'll say the low end is 5. And now it wants the high end. We'll say that's a 10. And we'll start off by checking a number that is in the range. So let's say 7. So we've hit our breakpoint, so it stopped, and it's showing us what's currently stored in the computer's memory in our debug interface. So high is equal to 10. That's just what we input. Low is equal to 5, what we input. And num equals to 7, also what we input. We can also see our lines variable and our title variable, which were set up here to make our nice titles. So now we're going to step over this, and hopefully we will get the result of what's going to happen when num is greater than equal to low. So in this case, num is 7. So 7 greater than equal to low. Low is 5. So that should be true. Let's see what happens. So we can see a new variable, greater than low, is equal to true. So this was true. The next line we're going to evaluate is less than high. And that's going to be set equal to num less than equal to high. So num is equal to 7. High is equal to 10. So is 7 less than equal 10? It should be. And the result of this, which should be true, is going to be stored in less than high. Let's see what happens when we advance. We can see that we get a less than high variable in the computer's memory. It's type Boolean, and it is true. So both of these were true. Our next test down here is greater than low and less than high. So both of these store Boolean values. And right now, greater than low is true, and less than high is true. So true and true should result in a true value, and that's going to be stored back in range. Let's see if that's what happens. And we can see range was added, and it has a true value. So the final thing is going to be output is the number is in the range, and print is going to take in the value of in range. So we should get output that says the number is in the range, true. Let's see. And we do. So it worked in that case. We inputted a number, it was in the range that we gave it, and we got a true. Everything's good so far. Okay, I'm going to add the breakpoint to the last line this time, and we're going to run it again, and we're going to give it some different values. So the lower end of the range this time, let's make it 2. The higher range, we can make it 100. And this time we're going to give it a value outside of the range. So let's try outside of the very end. So let's go like 999, which should be outside of the range because it's greater than 100. So we stopped right at the last line because that's where our breakpoint is, and we're in debug mode. And we have a list of all the variables. So let's look here. You also notice that debug mode also prints almost like a comment beside it to tell you what the value was. So in this case, greater than low is true. And that makes sense because if we think about it, num, which was 999, greater than equal to low, which is 2, is going to be true because 999 is greater than 2. Now here's why this is going to result in a false overall. Num less than equal to high. So right now num is 999 and high is equal to, I believe it was 100, yes. So that's going to be false because 999 is not less than 100. So that returns a false. So when we get to this line and we're comparing them, greater than low is true and less than high is false. So true and false results in false because one side is false. That means and is going to return false. So when we run the last line, we should get the number in the range, and then it should say in range is false. And we can even see that in our variables. In range is currently equal to false. And we can see in the console, we get the number in the range is false. Okay, and we are back, and on the screen, we just have another example run of the program. One thing I will mention is the way this is currently coded won't work if the user puts invalid input. So if they give a low that's actually higher than the high they input, it's not going to give us sensible output. And once we start talking about if statements, we'll see ways we could fix that. But what if we wanted to modify this program to do the opposite thing? What if we wanted to change it such that it would check if a number is not in a range? And here is one possible solution. So in here right now, there are some changes, like we have changes to strings and comments to say not. And we also changed the variable names a little bit, I believe. But those aren't the important updates. The important updates are these ones to the operations. So we've changed to num less than low and num greater than high. Before it was greater than equals and less than equals. And we've also changed the logical operator to or from and. So this change makes it so that if low is 2 and high is 5, the result will only be true if num is less than low, or if num is greater than high. If either of these conditions are true, we know that num is not in this range. So we've changed from focusing in this very specific range to the opposite. So before we had to have both conditions true to be in that range, and now it's the opposite. So either condition can be true. If it's less than low, it's not in the range, or if it's greater than high, it's not in the range. So I did mention that there is more than one solution. Another approach we could have taken is simply adding the not operator to negate the result of the first program. This is effectively the same as the changes we just saw. And if you think about it, it's pretty easy to see why. If the first program told us if a number is in a range inclusively, then if we inverted that, negated it with not, then it would tell us that it's not in a range exclusively. So either approach would work and are pretty much equivalent. So before we move on to anything else, we should talk a bit about order of evaluation. Just like the mathematical operators we saw in a previous video, the comparison and logical operators also have an order of operations that we should be aware of. So just like in arithmetic, parentheses have the highest order of operation. So they're always evaluated first. then the arithmetic operators, then comparison operators, then the not operator, then and then finally the or operator. So this may seem like a trivial point, but we're going to take a look at a case where this might be important for our code. So in this example, we want to check if a student is allowed to pass a course that has a few special requirements. The first special requirement is that they have to have an average over 65, and that is exclusive. So it can't be equal to 65, it has to be over. The second is that they must have submitted 2 or more assignments, so that's inclusive. And third, they must have submitted either 5 or more assignments, or alternatively, they could have attended 4 or more labs. This means for that last requirement, they have a choice. They could either attend 5 classes or more, or 4 labs or more to pass. Trying to make one logical expression to solve all of this all at once can be a bit complicated. It's better to break it down and try to turn it into simpler conditions, to employ sort of a divide and conquer approach. And this is usually a good strategy when we're trying to solve programming problems. First, let's start with that first requirement. This requirement is rather straightforward. It's simply saying that the average has to be over 65. Since it has to be over 65 and not equal to it, we just use a greater than operator here. The second requirement is also fairly simple. They just have to have 2 or more assignments submitted. Since it is inclusive, we use the greater than or equals operator. The last requirement is where things get a bit trickier, as this is actually 2 different conditions. First, they must have attended 5 or more classes, or alternatively, they must have attended 4 lab sessions. Now, how do we combine these conditions together? We know the first 2 requirements must be true for them to pass, so we can use the AND operator here. The last requirement must also be true. But how do we capture that alternative they have? They can either attend class or attend labs. They don't have to do both. If we use AND, it would mean that both conditions have to be true, but we want either. So we have to use an OR. So this might sound okay, at least linguistically. They must have an average over 65, and 2 or more assignments, and a class attendance of 5 or more, or attend 4 or more labs. But there is a problem here. This is a bit ambiguous. Does it mean that they need an average, assignments, and class attendance, but alternatively they could just attend 4 labs and that's fine regardless of the other requirements? Or does that OR apply to class and lab attendance only? The issue is that you could read it either way. So the way Python resolves this is with the precedent rules we just saw. Recall that AND has a higher precedence than OR, which is a bit of a problem for the way we've written this right now. It means that Python would interpret this incorrectly. To make what we mean clear and unambiguous, we need to add some parentheses, sort of like this. Let's try tracing through an example and give some values to this problem. Here I have rewritten this logical expression as we might see it in Python. Let's see how it will play out with these values of average equals 72.5, 2 assignments submitted, class attendance 3, and lab attendance 9. To figure out what happens first, we need to follow the order of evaluation. And the first item to evaluate are parentheses. So we have to evaluate what's inside of these parentheses first. And inside the parentheses, the next item to evaluate would be the comparison operators. They have higher precedence than the OR operator, so we evaluate them first. So in this case, class attendance was too low, so we get a false. But lab attendance was 9, which is more than enough, so we get a true value. The next step is to evaluate the OR operation as it's still inside the parentheses. We need to completely resolve that before we evaluate anything else. This results in a true value, as if either side is true, OR will return a true value. We now have everything evaluated inside of the parentheses, so the next operation in the hierarchy would be the comparison operators that aren't inside parentheses. And we have 2 here, so we're going to evaluate those first. So average is over 65, so we get a true value, and assignment is equal to 2, so we get a true value resulting in the expression true and true and true. Since everything is true, the overall result is true, and this student can pass the course with these values. So everything seemed to work out. But what happens if we had forgot those parentheses? Will we still get the correct values in all cases? Here we have a new case where the student has an average of 25.34, but we forgot to add the parentheses to our logical expression. Do you think it will still give the correct result? So with no parentheses, the first order of operation to complete would be the comparison operators. So in this case, average is less than 65, so we get a false. Assignment is equal to 2, so we get a true. Class attendance is too low, so we get a false. And lab attendance is more than enough at 9, so we get a true value. But what do we evaluate next? Well, if you recall, AND operator has a higher precedence than OR, so we evaluate that first. And false and true is going to result in false. Next, we evaluate the next AND, which results in another false, because false and false is false. So lastly, we are left with false or true. And that's going to evaluate to true, because with or either side, being true results in a true. But that's not correct. The student had a failing average. They should not pass. And this is why parentheses are important in these kinds of statements. Without them, we would get incorrect results in some cases. It's also why those order of operations matter so much. So make sure that you think about that while you're constructing statements like this. So if you're interested in how this would play out as a Python program, what I have on screen right now captures this logic correctly. Note that the parentheses around the or part of the statement. So this is the correct version. And we would get the correct result if we were to run it. Here's with the same values. And you can see that we are correctly getting false. The last thing I should quickly cover in this video is chain comparisons. While not all programming languages support this, Python allows us to use a shorthand for statements such as less than B and B less than C. Chain comparisons allow us to chain this together into one comparison that has the same meaning. This works for the other comparison operators as well, such as equals, not equals, greater than, and so on. So it can be a useful shorthand to make your code cleaner, but either method is fine in almost all cases that we'll see. That's all I have for you in this video. These operations alone might not seem very important now, but in our next video on branching and if statements, you'll see how we can make use of them to control the flow of our programs and start making some far more interesting code. Thanks for watching and have a great day.